Welcome to another episode of I Am Nano.
Putting the I in I Am Nano, I am your host, Irfani.
And putting the M, I am your other host, Monica.
And today we're going to be talking about getting rid of drug waste in water supply using nanophotocatalysts that are activated by sunlight.
That's right. We are discussing research from Tsinghua University and Guangdong University of Technology. In this work, polymers were combined with titanium dioxide, TiO2, nanoparticles. This combination can break down molecules when exposed to sunlight. And as you said, the application was for breaking down and removing pharmaceuticals that are found in our water supply.
Right. Now, the first question is, why do we even have pharmaceutical agents, in other words, drugs, in our water supply?
Good question. And two main reasons, excretion and disposal. For one thing, any unused prescriptions, unfortunately, often get flushed down the toilet or sink, or thrown out in the garbage. And they find their way eventually into wastewater treatment plants, which are not equipped to get rid of active drug compounds.
So, treatment plants can remove chemicals and from materials and microorganisms, but not highly concentrated drugs.
Exactly. About 93% of highly concentrated active drug compounds leave the treatment plant. So these chemicals essentially pass through the wastewater treatment facility or septic system process and accumulate in rivers, lakes, and groundwater and aquatic organisms.
Right, so not good. And according to the US Geological Survey, over 80% of waterways tested in the United States show traces of common medications such as acetaminophen, hormones, blood pressure medicine, codeine, and antibiotics.
Yes, and that is in the US alone. In the EU, 90% of pharmaceuticals found in the environment are excreted by people and animals and come from urban wastewater, sewage sludge, and manure. It has been stated that emissions from manufacturing and the disposal of unused pharmaceuticals are also a large resource for this.
I'll also add, antibiotics were predominantly measured in South Asian regions. Now, in Vietnam, 90% of urban wastewater is released back into the environment untreated. Now, the thing is, even if the wastewater is fine for human consumption and has low levels of pharmaceutical agents, even very low levels of compounds can severely affect the aquatic wildlife.
Yes, exactly. So it's a problem to the aquatic environment because pharmaceutical compounds are specifically designed to affect biological organisms. That's their
Mhm,
intended purpose. So
mhm.
while environmental concentrations are below acute toxicity levels, the main concern is the chronic or synergistic effects of this medley or cocktail of pharmaceutical compounds that humans have created that are found now in the water.
Mhm. Now, although extensive scientific study and additional analysis is needed to better understand the impact presented by these chemicals, of concern is the development of antibiotic resistant bacteria populations. Now, a number of studies have shown a decrease in antibiotic effectiveness due to its widespread presence in the environment.
Not good. And I'll also add that endocrine disruption in fish near wastewater treatment plants has already been seen. Endocrine or hormonal gland disruption is the most widespread and documented effect that pharmaceuticals have on aquatic organisms.
Mhm.
Chronic exposure to these endocrine disruptors, such as the compounds used in birth control, can actually feminize male fish and thereby weaken their ability to reproduce.
Yeah, so it creates a cycle where we eat fish that might not be 100% healthy due to these sorts of chemical exposures over the long term.
It is concerning. And I think in our episode 16, Dr. Rob was researching similar effects
Mhm.
to this. So that would be a good reference for this type of research as well. And so the question now is, how can nanotechnology help us here? From our lit update today, the researchers optimized the use of TiO2. But let's first understand how we can purify water in treatment plants in the first place.
Right, so the conventional techniques include physical, chemical, and biological systems such as sedimentation and chemical disinfection. The advanced techniques include membrane filtration and advanced oxidation processes, AOPs such as ozonation, UV photolysis, photocatalysis, and Fenton reaction. Now, huge disparities have been observed in removal efficiencies of these pharmaceutical compounds due to the treatment applied at individual wastewater facilities. And also, the contaminants' physical chemical properties and varying operation parameters, such as the pH, solids, and hydraulic retention time, and microbial activity, can significantly influence their removal efficiency.
Many parameters to be aware of. So the researchers here focused on advanced processes, as you mentioned, the AOPs.
Mhm.
This was with TiO2, a photocatalyst. And this photocatalyst is widely used in wastewater treatment to catalyze, in other words, start the reactions of contaminant breakdown. Its wide use is due to its stability and non-toxicity, and the fact that it's very practical. However, it can only catalyze under UV light.
And why is that a downside? Aren't UV rays simply from sunlight?
Yes, but sunlight is only about 5% UV light. So the
Mm.
performance of TiO2 under natural sunlight is limited,
Mhm.
but they remove pharmaceutical chemicals really well. So we have to develop systems that work at a high efficiency under sunlight.
Right. And another disadvantage of titanium dioxide and similar materials are the high cost for preparation. So, some studies have shown the making of new molecules and polymers to act as catalysts instead. One very promising candidate are oxygen and nitrogen linked heptazine based polymers dubbed ONLH.
Right. So in this study, they said, why not take one of the best polymers and combine it with one of the best photocatalysts?
Mhm.
So in their work, they compared ONLH and then just TiO2 nanoparticles, and then the new material of the nanocomposite of both TiO2 and the ONLH polymer together.
It's very clever and thorough. So, what did they find?
They had so much data and it was very well put together, I might add. Basically, key takeaways are the making of this new material and the observation that broad spectrum sunlight can work in activating reactions with it, rather than just the limited UV rays. In this study, 10 different drugs were broken down, of which propranolol was broken down the fastest. And the authors state that the toxicity of the solution with the reactions to aquatic organisms was decreased as the toxic chemicals were removed from the water system. Overall, this system can reduce the production of toxic transformation products and then decrease the harm being caused in our water cycles.
So very cool. And the authors also mentioned that the TiO2 and LH was also effective for the treatment of propranolol in tap water, surface water, and wastewater effluent, demonstrating the suitability of this novel system to efficiently remove emerging pharmaceuticals in both drinking water and wastewater. Now, this propranolol is really pesky and has been linked to cytotoxicity, gene expression, enzyme activity, and increased estrogen activity. It's been very hard to remove them in this ecological environment.
Yes, that's right. And propranolol is used in lots of medications to treat high blood pressure and reduce the risk of stroke and heart attacks, as well as reduce anxiety. So it's really everywhere.
Yeah, I heard some athletes use it, right? Like as a performance enhancer because they just decrease your anxiety. So, you don't get as nervous and can perform better. And I guess this also applies for musicians, public speakers, and actors as well.
Exactly. So many people in the world use it. So finding a way to break down this propranolol is very important. And now
Mhm.
the study shows that it can happen with this hybrid polymer and TiO2 nanoparticle composite in sunlight. Amazing.
Yeah, really cool. I really look forward to incorporating this nanotech in these wastewater facilities very soon.
Same. It's very lit work.
Yeah. All right, everyone. That is all the nano for today. Take care.
And stay curious.